So 4.4, we've got derivatives of exponential and logarithmic functions. You probably noticed, but overall, I personally think that the exponential ones are the easiest. The logarithmic ones obviously have a little bit more to them. There's one of them that always trips me up, like that I always forget which order it is until I'm like using it a lot, and then by next year I'll forget again what it is. So, but the first literally 28 problems just say find dy dx, so it's just using the derivatives that you've got. So number 2, we've got y equals e to the 2x. And so when we take the derivative, we've got y prime is equal to, anytime you have like an e to a value, it's always going to be that copied down exactly and then chain rule whatever its exponent is. So e to the 2x, and then the derivative of this part obviously is just 2, so I just throw that 2 out front, so 2e to the 2x. I don't know why that reminded me, but tomorrow you can either sit in my room or you can go sit in Mr. Foster's room for study hall to work on your stuff, because I am going to be downstairs. We're having a math meeting, and I told him we were super ahead in this class. This is the only class I could really like afford to give up right now. So I may not be down there like the whole time. I'm hoping it's not going to be the whole hour, but I don't know. But anyways, you're welcome to sit in here if you want something like quiet, but if you want to go in study hall, if your friends are in study hall, that's fine too. Okay, let me turn this off. 4. Y equals e to the negative 5x. So, copy it down exactly, e to the negative 5x, and then just take the derivative of this part, just negative 5, put that out front, and that's it on those ones. So obviously if they stayed that easy, that would be nice, but we're going to end up with some product rules, some quotient rules, and things like that. They're still not, obviously, they don't really get any harder as far as like the derivative itself. It's just combining it with everything else. So 8, y equals x squared e to the x minus x e to the x. All right, so we've got a product rule. Well, technically I have 2 product rules here. And so I'm just going to work my way across. So the first one, we would have 2x e to the x. So I took the derivative of the first part, plus the first times the derivative of the second. Well, that's just x squared e to the x. Because this is just an x up here now, I don't have to do any chain rule to that. And then I'm just going to do the same thing over here. Minus, I would probably bracket this off instead of putting the negative sign with the x, but it's really just a preference thing. So the derivative of the first is just 1, so I have e to the x, and then plus x e to the x for that, and then I just need to simplify it if I can, which it looks like the only thing I can simplify is the 2x e to the x and the x e to the x, so that would be, let's see, I've got x squared e to the x, and then 2x e to the x minus x e to the x, with that minus sign out there, would just be plus x e to the x and then minus e to the x by itself. I tried to do it so that the x's are in descending order, but they're not as picky when it involves like exponentials if it is in that order. I just think it looks nice that way. That's why I do it that way. But that's it on that one. 10, y equals e to the x squared. So I'm going to let you see if you can tell me what the derivative of this one would be.
2x e to the x squared?
Yep. And a lot of times, like, the book is going to put that x squared in parentheses. I think it's just for you to be able to see it like when it's typed out, but I don't usually put that. Anyways. Okay. So obviously that's all been e to the whatever. They're the easiest ones overall. But if we have something like a number raised to a power, so like what it would have been listed in your notes as the derivative of a to the x, that derivative is a to the x, so you copy it down, and then the ln of whatever that number is that the base is. So with one like number 12, we've got y equals 9 to the negative x. So the first time you copy it down exactly as it is. So it would be 9 to the negative x times the ln of the base, which is 9. Now then with the u part where that comes in is we end up doing it times du dx, which just means times the derivative of whatever your exponent is, which in this case is just -1. So I'm just going to throw my negative sign out front. Remember if it's this one or if it's the log base a of x is the one that I struggle to remember the most for some reason. 14, y equals 3 raised to the cotangent of x. So this one's obviously got a little bit, well, I say it's a little bit more of a chain rule. Still just chain rule, but when you get the trig stuff in there, obviously it adds another level of complexity to it. So y prime is equal to, copied down exactly as it is, so 3 raised to the cotangent of x. Then the ln of the base, which is the ln of 3. Then I need the derivative of cotangent of x. Do you remember what the derivative of cotangent of x is? If not, it's okay.
Negative cosecant squared of x.
Yep. So I'm going to put the negative out here, and then I'm just going to do cosecant squared of x over here. I just put it in parentheses because that way it shows that it's not with the ln of 3. It kind of like shows it's its own thing. But so obviously it doesn't exactly look pretty, but yeah. Yeah, it is what it is. It's like kind of, usually in math you're simplifying things, and then I feel like with derivatives it's usually the opposite, which, whatever. Let's see, what other derivatives do we have in this section to hit? All right, so those are exponentials, not too bad. Honestly, probably the easiest ones. But the next ones get into the derivatives of logs, it looks like, for the rest of the, 15 through 28 are all log derivatives. So the derivative of the ln of x is the most basic. It's 1 over x. And then if we have something else like the ln of something, then it's obviously 1 over whatever that value is times the derivative of whatever that inner part is. But in this next one, we've got the ln of x and then that whole thing squared. Forgot the y. So we have to treat this like a chain rule on the outside first. And so we're going to take the derivative of the outer part and then the derivative of the inner part. So we have y prime is equal to 2 times the ln of x, and then times the derivative of the inside, which is just 1 over x in this case. I'm okay if you leave it like this. You might want to put in parentheses like the 2 ln of x so that you don't accidentally cancel these x's here. And just be left with like the ln of 1, because obviously that's not what that actually is. But what you'll probably find is that the book is most likely writing them like this, 2 ln of x over x. Okay. But again, purely a notation thing. Makes no difference to me which way you choose to do it. Let's see, one with something inside, not 10. Why I wrote that. 18. y equals the ln of inside 10 over x. So as far as like your initial part of your derivative, it probably doesn't really matter if I rewrite what's inside, but for taking the chain rule of this, it probably would be easier to think about this like the way we've done with other stuff, is 10x to the negative 1 inside. But it's not really going to make that much of a difference. So now to take the derivative of this, I would have 1 over everything that's inside here. So I'm just going to do it with the modified version for now. So 1 over 10x to the negative 1. If I had left it as 10 over x, then I would just be doing a keep change flip. With this, I'm just going to be moving this to the top, so really not going to matter. And then times the derivative of this inside piece would be negative 10x, take 1 away, to the negative 2, which obviously is going to move that to the bottom, so this is going to end up reducing down a lot. But we would have technically, well, the 10s are going to cancel, so I'm going to have negative 1 on top, or well, negative 1. And then if I add this negative 2 that's like on the top to the x that's on the bottom, then I'll have negative 1 plus 2, so this is just going to be negative 1 over x after everything is canceling for my final derivative. What's next? One more like that, and then we'll move into a slightly different one. 20, I've got y equals x ln of x minus x. So initially here I have a product rule to deal with. So derivative of the first is just 1 times the ln of x plus x times the derivative of ln of x is 1 over x. And then over here minus the derivative of x is just 1. So this x and 1 over x are going to cancel here and just leave me with a 1. So I have the ln of x plus 1 minus 1. So that ends up just being y prime is equal to the ln of x. Um, 22. So the other derivative that we haven't touched on yet, I think it's the last one in here. Well, other than just like the power rule, but the last specific type of derivative is the log base a of x, which I honestly have the hardest time with this one. So the log base a of x derivative is, I have to write this one out or I forget it, 1 over x times the ln of a, because I'm going to need that on this next one. So 22, we've got y equals log base 5 of the square root of x. So again, I would probably rewrite that square root of x as x to the 1/2. Probably put that in parentheses if I rewrite it though. So now to do the derivative, y prime is equal to 1 over whatever's inside your parentheses here, so x to the 1/2. You can write it as the square root of x, however you want to do it, times the ln of the base, which is 5, and then times the derivative of whatever's inside for your chain rule, so 1/2 x to the negative 1/2. So that's going to move this x to the negative 1/2 to the bottom, and so I'm going to end up with 1 over x to the 1/2 ln of 5 times 1 over 2 x to the 1/2. Well, multiplying that, we add the exponent, so that ends up just going to be 1 because square root of x times square root of x is just x. So I'm going to end up with 1 over 2x ln of 5. And again, the order that we write that doesn't really matter. I just usually try to put the ln of whatever by itself so it's not confusing as to what's inside of it, but all right. One more of these. Let's see. 24. I've got y equals 1 over the log base 2 of x. So much like with any of these, when it's a 1 on top, I can either rewrite this as the bottom to the power of -1 and then do a chain rule that way, or I can leave this as it is and just do a quotient rule on it. Which, do you have a preference?
Move it into the top.
Okay. So this would be log base 2 of x all raised to the -1. So derivative here, y prime, is going to be -1 times log base 2 of x to the -2. And then times the derivative of the inside. So we've got 1 over x times the ln of the base, which is 2. And then I just need to simplify it. So this log base 2 of x is going to move to the bottom. So I end up with -1 on top over, it doesn't really matter, but log base 2 of x all squared times x ln of 2. So again, not necessarily the prettiest, but not overly complicated. So the biggest things in this section are just memorizing those 4 different derivatives, and then paying attention to their chain rules and when they have them and stuff like that. But nothing too terribly crazy. So any questions about any of this? That's pretty much all in this section. So what I would say is 1 through 25 odd. However, if you feel like especially with those first ones that are essentially just like e to the something x, don't feel like you have to do every single one of them. I mean, it's not that many problems, and we still literally have almost 30 minutes today, and you have all of tomorrow to work on them. So if you're like, I don't want to do these right now, I want to do these tomorrow, or get them all done today and then just chill tomorrow during this class, that's fine too. I don't care. But anyways, that's it.